All right, here's a problem a little bit more involved than the other washer problems we've been doing. This is in section 7.2, number 46 in the book, and it's an even problem, so it's not online. But what we're doing here is we've got this line y equals x. It goes up here to 0.111, comma 1. And then we also have the parabola y equals x squared that goes up to that point. And instead of revolving around the y-axis or revolving around the x-axis, we're going to revolve this area between those two curves around an arbitrary point, an arbitrary line. Let's say we're going to revolve it around this line x equals 1. So this is a little bit more involved. So you can do this, you could take any area and you can rotate it around any line that you want. So here's just this line out here, x equals 1. It's a vertical line. Of course, it goes through the x-axis at 1. So you draw another line over here on the other side, another parabola over here on the other side, and we're revolving this area around that x equals 1 line. Now what you have to do is you have to figure out the two r's. So the area is still going to be, or the volume is still going to be pi times the integral of big R squared minus little r squared. And in this case, it's going to be dy because we're, the skinny part is along the y-axis. So we just have to figure out what big R is and what little r is with respect to this line x equals 1. So the big R is going to go from the line to there, to that point right there. That's big R. And little r is going to go from the line to that point right there, and that's little r. So what are those distances there? And all they're going to be is, this is the y equals x line, but this distance from here to here is going to be the x coordinate of that distance, which is 1, minus the x coordinate on the line, which is just y. So that r distance here is going to be 1 minus y. Okay? So that's a little bit confusing. So any point on this line, how far is it away from the x equals 1 line? Well, it's just 1, take away its x coordinate. And in this case, the x coordinate is just the same as the y coordinate. Because we want to get everything in terms of y, we make this r equal to 1 minus y. If we're doing along the x-axis, it would be 1 minus x, because we want to have x's in our integral. Because we want to have y's in there, we're going to say that distance is 1 minus y. So that's big R. Little r is even more confusing. It is going to be 1, that's the distance here, minus, and the x coordinate there is going to be x squared, or I'll do the y coordinate. If y is equal to x squared, that means x is equal to the square root of y. So if I want to know what that x coordinate is there, because x is equal to the square root of y, I could say 1 minus x, but I don't know what x is because I want to have y's in my integral. So I say 1 minus the square root of y. So this distance here is going to be 1 minus the square root of y. So what we have is our volume is going to equal pi times the integral. Big R squared is going to be 1 minus y, and that's squared. And then little r squared is going to be 1 minus the square root of y, and that's squared. And then, of course, there's going to be a dy at the end. Okay? And we're integrating along the y-axis, going to go from 0 up to 1. So that's the limits of our integration. Okay, so it's pi integral big R squared minus little r squared, and then dy. And everything in here has got to be in terms of y because we've got a dy at the end. All right? So we'll add up an infinite number of those skinny little slices from 0 all the way down up to 1. All right, to do that, we have to expand this. So this, I'm going to FOIL this. I'm going to get 1 minus 2y plus y squared. This is minus, and then I'm going to FOIL this. I'm going to get 1 minus 2 root y plus y. Root y times root y is plus y. So I'm going to distribute that negative. It's going to be 1 minus 2y plus y squared minus 1 plus 2 y to the 1/2 power, and then minus a y. So simplifying this, the 1's cancel. I've got a y squared, and I've got a negative 2y and a negative y, so I've got minus 3y's. I've got a plus 2 root y, so it's going to be plus 2 y to the 1/2, and dy that whole thing from 0 to 1, pi times that. Now I'm going to integrate these, so I'm going to get y cubed over 3 minus 3 times y squared over 2 plus 2 times y to the 3/2, and then times 2/3. I'm going to evaluate that whole thing between 0 and 1, and then I'm going to multiply it times pi. So when I put 1 in here for y, I get 1/3. And another 1 in here for y, I get minus 3/2. Another 1 in here for y here, I get plus 4/3. And then it's going to be minus 0, minus 0, minus 0. Because when I put 0 into all those, I just get 0. So that is 1/3. I'm going to multiply by 2 over 2. Here I'm going to multiply by 3 over 3. And here I'm going to multiply by 2 over 2. So I get 2/6 minus 9/6 plus 8/6. So 2 take away 9 plus 8, that's 1/6 times pi. So my answer is pi over 6. So if I take that area there and I rotate it around the line x equals 1, I get an area of pi over 6. So pretty amazing. Practice that.